Guten Morgen, Berlin. Good morning. All right, I'm just going to get started because I've got a lot to talk about, and I'm very, very excited to be here. I am excited to talk about the web. I've been thinking a lot about the web. I think a lot about the web all the time, but this year in particular, thinking about where the web came from, asking myself where the web came from, which is kind of a dumb question because it's pretty obvious where the web came from. It came from this guy. This is Tim Berners-Lee, and he is the creator of the World Wide Web. It was 30 years ago, March 1989, that he wrote a proposal while he was at CERN, very dull-looking proposal called Information Management, a proposal that had incomprehensible diagrams trying to explain what he had in mind. But his supervisor, Mike Sendall, saw the potential and scrawled across the top, vague but exciting. And Tim Berners-Lee starts working on this idea he has for a global hypertext system. And he starts creating the world's first web browser, the world's first web server, which is this next machine, which is in the Science Museum in London. A lovely machine, the next box. I have a great affection for it because earlier this year I was very honored to be invited to CERN, along with this bunch of hackers, to take part in a project related to the 30th anniversary of that proposal. I'll show you a video that explains the project.
So we came to CERN this week in order to create some sort of modern-day interpretation of the very first web browser.
So the project is to restore the first browser which was developed by the inventor of the web. And the idea is to recreate an experience for the people who could not use the web in its early days, to have an idea how it felt to use the web at that time.
I think the biggest difficulty was to make the browser work in the next machine that we had.
We really needed to work with an original next box in order to really understand what that experience was like, in order to be able to write some code to replicate that experience.
So my role is code, so generating the code to create the interactive aspect of the World Wide Web browser, recreated browser. So it's very much writing JavaScript to kind of create all the next operating system kind of UI, making requests to servers to go and get the HTML and massage the HTML back into a format that looks good in this the World Wide Web browser, and making sure that we actually end up with a URL that goes into production that people can come and visit and see their own web pages. And the tangible software is what I'm responsible for, so I have to make sure it all gets done. Otherwise we have no browser to look at, basically.
We got together a few years back to do a similar sort of hack project here at CERN, which was creating the world's second ever web browser, which was the line mode browser. And we had a lot of fun with it, and it's a great bunch of people from all over the world. So it's been really great to get back together, and it's always amazing to be here at CERN, to be at not just the birthplace of the web, but the most important place on the planet for science. And yeah, it's just been a lot of fun, and I kind of don't want it to be over because we're in our element, hacking away, having fun, and just soaking up the atmosphere. And we're getting to chat with people who were there 30 years ago, Jean-Francois Groff and Robert Caillou, these people who were involved in the creation of the World Wide Web. To me, that's amazing to be, surrounded by so much World Wide Web history. So the plan is that this will go online, and anyone will be able to access it because it's on the web, and that's the beautiful thing about the web, is that anyone can visit a website. And so everyone will have the opportunity to try using the world's first web browser and maybe see what modern web pages would look like if they were passed through this first web browser.
Well, spoiler alert, the project was a success, and you can indeed look at your websites in a recreation of the first ever web browser, and this is the URL, it's worldwideweb.cern.ch. Now, so success, that was good, but as you could probably tell from that video, Remy was the one basically making this all happen. Like, he was the one writing the JavaScript to recreate this in a modern browser. This is the first ever web page viewed in the first ever web browser. As you probably gathered again, I was really fascinated by the history of the web. Like, where did it come from? And the people who were there at the time and getting to pick their brains. So I spent most of my time working on the accompanying website to go with this project. And I was creating this timeline. Because this was to sort of mark the 30th anniversary of this proposal, I thought, well, we can easily look at what's happened in the last 30 years, you know, websites, web servers, formats, standards, all that stuff. But I thought it would be fascinating to look at the previous 30 years as well and try and figure out the things that were happening that influenced Tim Berners-Lee. You know, in terms of hypertext and networks and computing and all this stuff. But I'd kind of given myself this arbitrary cutoff point of 30 years to make this nice symmetry of it being the 30th anniversary of the World Wide Web. I could go further back. I could start asking, well, you know, what happened before 30 years ago? What were the biggest influences on Tim Berners-Lee and the World Wide Web? Now, if you were to ask Tim Berners-Lee himself who his biggest influences were, he'll give you a straight-up answer. He will say his biggest influences were Conway Berners-Lee and Mary Lee Woods, his father and his mother, which is fair enough. Like, normally when you ask people what the influences are, they say, oh, my parents, you know, they gave me a loving environment, they kindled my curiosity and all that stuff. And I'm sure that's true. But in this case, it was also a big influence in a very practical sense in that both Mary and Conway worked on the Ferranti Mark I. That's where they met. They were programmers. Tim Berners-Lee's parents were programmers on the Ferranti Mark I, a very early computer. This is in the 1950s in Britain. So, okay, this feels like a good origin story for the web, right? They were working on this early computer, but it's an early computer. It's not the first computer. Maybe I need to go back further. How far back do I go to find the first computer? Is this the first computer, the Antikythera mechanism? You can see this in a museum in Athens. This was recovered from a shipwreck. It was recovered at the start of the 20th century, but it dates back thousands of years, a mechanism for predicting the position of stars and planets. So it does calculations. It is a calculating device. Not a programmable computer as such, though. If thinking about the origins of the idea of a programmable computer, I think we could start to look at this gentleman, Charles Babbage. This is half of Charles Babbage's brain, which is in the Science Museum in London, along with that original Next box that the World Wide Web was created on. The other half is in the Computing History Museum in California. Charles Babbage lived in the 19th century and kind of got a lot of seed funding from the UK government to build a device, the difference engine, which would do calculations. Later on, he scrapped that and started working on the analytical engine, which would be even better, a 2.0 version. It never got finished, by the way, but you know, it was a really amazing idea because it almost had you could see the architecture of like a central processing unit. This idea, but it's still fundamentally a calculator, a calculating machine. The breakthrough in terms of programming maybe came from Charles Babbage's collaborator. This is Ada Lovelace. She was translating documents by an Italian mathematician about difference engines and calculations, and she realized that, hang on, if we're doing operations on numbers, what if those numbers could stand for other concepts, non-numerical concepts, you know, like words or you know, thoughts? Then we could do operations on things other than numbers, which is exactly what we do today in modern computing. You know, if you use a word processor, you're not processing words, you're operating on ones and zeros. If you use a graphics program, you're not actually moving pixels around, you're operating on ones and zeros. So this idea of how anything could stand in for ones and zeros, for numbers, kind of started with Ada Lovelace. But as I said, the difference engine and the analytical engine, they never got finished. And this was kind of a dead end because it turns out they weren't an influence. Later on, for example, this genius, who was definitely responsible for the first working computers, Alan Turing, he wasn't aware of the work of Babbage and Lovelace. Which is a shame. He was kind of working in isolation. And he came up with this idea of the the universal machine, right? The Turing machine, given an infinitely long tape and enough state, enough time, you could calculate literally anything, which is pretty much what computers are. So he's working at Bletchley Park, breaking the code from the Enigma machines, and that leads to the creation of what I think will be the first programmable computer. This is Colossus at Bletchley Park. And this was created by the colleague of Turing, Tommy Flowers. And it is programmable. It's using valves, but it's absolutely programmable. It was top secret, so even for years after the war, this was not known about. So in the history books, even to this day, you often see ENIAC listed as the first programmable computer. But I think that honor goes to Tommy Flowers and the Colossus. By the way, Alan Turing, after the war, after 1945, he did go on to work to keep on working in the field of computing. In fact, he worked as a consultant at Ferranti. He was working on the Ferranti Mark I, the same computer where Tim Berners-Lee's parents met when they were programmers. As I say, that was after the war ended, 1945. Now, we can't say that the work at Bletchley Park was responsible for winning the war, but we could probably say that it's certainly responsible for shortening the war. That if it weren't for the work done by the code breakers at Bletchley Park, the war might not have finished in 1945. 1945 is the year that this gentleman wrote a piece that was certainly influential on Tim Berners-Lee. This is Vannevar Bush, scientist, thinker, and in 1945 he published a piece in the Atlantic Monthly under the heading, "A Scientist Looks at Tomorrow." He publishes As We May Think. And in this piece he describes an imaginary device. It's a mechanical device inside a desk, and the operator is allowed to work on reams and reams of microfilm and to connect ideas together, make these associative trails. So this is kind of like hypertext before the word hypertext has been coined. And Vannevar Bush calls this device the Memex. So that's published in 1945. Also, 1945, this young man has been drafted into the US Navy, and he's shipping out to the Pacific. His name is Douglas Engelbart. And literally, as the ship is leaving the harbor to head to the Pacific, word comes through that the war is over. Now, he still gets shipped out to the Pacific. He's in the Philippines, but now instead of fighting against the Japanese, he's lounging around in a hut on stilts reading magazines, and that's where he reads As We May Think by Vannevar Bush. Fast forward to years later, he's trying to decide what to do with his life, other than, settle down, get married, have a job, that kind of thing. He's thinking, no, I want to make the world a better place. And he realizes that computers could be the way to do this if they could implement something very much like the Memex. So instead of a mechanical device, what if computers could create the Memex, this kind of hypertext system? And he devotes his life to this and effectively invents the field of human-computer interaction. And on December 9th, 1968, he demonstrates what he's been working at. This is in San Francisco. And he demonstrates bitmapped screens. He demonstrates real-time collaboration on documents, working hypertext, and also he invents the mouse for the demo.
We have a pointing device called a mouse, a standard keyboard, and a special key set we have here. And we're going to go for a picture down in our laboratory in Menlo Park and pipe it up that'll show you from another point of view more about how that mouse works. Come in, Menlo Park. Okay, there's Don Andrews' hand in Menlo Park. And in a second we'll see the screen that he's working and the way the tracking spot moves in conjunction with movements of that mouse. I don't know why we call it a mouse. Sometimes I apologize. It started that way and we never did change it.
This was groundbreaking. The mother of all demos, it came to be known as. And this was a big influence on Tim Berners-Lee. And at this point, we have now entered the time cone of those 30 years before the proposal that Tim Berners-Lee made, which is good because this is the moment where I'd like to branch off from this timeline and sort of turn it around. The question I'm sure nobody is asking, because you saw there was a video link up there. Douglas Engelbart's in San Francisco, and he has a video link up with Menlo Park to demonstrate real-time collaboration with computers. The question nobody's asking is, who's operating the video camera in Menlo Park? Well, I'll tell you the answer to that question that nobody's asking. The man operating the video camera in Menlo Park is this man. His name is Stewart Brand. Now, Stewart Brand has spent most of the 60s doing what you would do in the 60s. He was dropping acid. This is all, kosher. This is when before it was illegal. He was on the Merry Pranksters bus with Ken Kesey doing all. On one particular acid trip, he literally saw the Earth, curving away and realizing that we're all on one planet, man. And he started a campaign with badges called "Why haven't we seen a photograph of the whole Earth yet?" I like the "yet" part in there, like it's a conspiracy that we haven't seen a photograph of the whole Earth. But he was kind of on something here, realizing that seeing our planet as a whole planet from space could be a consciousness-changing thing, much like LSD is a consciousness-changing thing. And sure enough, people did talk about the effect it had when we got photographs like Earthrise from Apollo 8. And he used those pictures when he published the Whole Earth Catalog, which is a series of books. But the Whole Earth Catalog was basically like Wikipedia before the internet. It was like this big manual of how to do everything. The idea was if you were running a commune, living in a commune, you needed to know about technology and agriculture and weather and all this stuff. And you could find that in the Whole Earth Catalog. It's quite influential guy, Stewart Brand. You probably heard the Steve Jobs commencement speech where he quotes Stewart Brand, stay hungry, stay foolish, all that stuff. Stewart Brand also did a lot of writing. After Douglas Engelbart's demo, he started to see that this computer thing was something else. Like this was, he literally said computers are the new LSD. So he starts really investigating computing and computers. He writes this great article in Rolling Stone magazine in 1972 about Space War, one of the first computer games you could play on a screen. But he has a wide range of interests. He kind of kicked off the environmental movement in some ways. And at one point, he writes a book about architecture. He writes a book called How Buildings Learn. There's a television series that goes with it as well. This is a classic book. The definition of a classic book being a book that everyone's heard of and nobody's read. And in this book, he starts looking at the work of a British architect named Frank Duffy. And Frank Duffy has this idea about architecture he calls shearing layers. The way that Frank Duffy puts it is that a building, properly conceived, consists of several layers of longevity. It's kind of different rates of change. And he diagrams this out in terms of a building, and you see that, you got the site that a building is on that's moving at a geological time scale, right? That should be around for thousands of years, we would hope. And you got the actual structure that could stand for centuries, and you get into like the infrastructure inside, the plumbing and all that. You probably want to swap out every few decades, basically till you get down to the stuff inside a room, the furniture you can move around on a daily basis. So you've got all these time scales moving from fast to slow as you move inwards into the house. What I find fascinating about this idea of these different layers as well is the way that each layer depends on the layer below. Like you can't have the structure of a building without first having a site to put it on. You can't move furniture around inside a room until you've made the room using the walls and the doors, right? So this idea of shearing layers is kind of fascinating, and we're going to get back to it. Something else that Stewart Brand went on to do, he was one of the co-founders of the Long Now Foundation. Anybody here part of the Long Now Foundation? Any members of the Long Now Foundation? It's a great organization. It's literally dedicated to long-term thinking. It was founded by Stewart Brand and Danny Hillis, the computer scientist, and Brian Eno, the musician and producer. And like I say, dedicated to long-term thinking. This is my membership card, made out of a very durable metal, because it's got to last for thousands of years. If you go on the website of the Long Now Foundation, you'll notice that all the years are made up of 5 digits. So instead of 2019, it would be 02019. Got to solve the Y10K problem. So they're dedicated to long-term thinking, to trying to think in the longer now. One of the most famous projects is the clock of the long now. This is a clock that will tell time for 10,000 years. And Brian Eno's done the chimes. They're generative. It'll never chime the same way twice. It chimes once a century. This is a scale model that's in the Science Museum in London, along with half of Charles Babbage's brain and the original Next machine that Tim Berners-Lee created the World Wide Web on. But this is just a scale model. The full-size clock is going to be inside a mountain in West Texas. You'll be able to visit it. It'll be like a pilgrimage. And construction is underway. I hope to visit the clock one day. Now, Stewart Brand collected his thoughts. It's a really fascinating project when you think about how do you design something to last 10,000 years? How do you communicate over 10,000 years? It's one of those really tricky design problems, almost like the Voyager Golden Record or the Yucca Mountain waste disposal. Like, how do you communicate to future generations? You can't rely on language. You can't rely on semiotics. Anyway, he collected a lot of his thoughts into this book called The Clock of the Long Now, subtitle Time and Responsibility, the ideas behind the world's slowest computer. So he's thinking about time. And that's when he comes back to shearing layers and these different layers of rates of change, different layers of time. And Stewart Brand abstracts the idea of shearing layers into something called pace layers. So what if it's not just architecture? What if any kind of system has these different rates of change, these layers? And he diagrams this out in terms of the human species. He said, think of humans. We have these different layers that we operate at. At the lowest, kind of slowest level, there's our nature, literally like what makes us human in terms of our DNA. And that doesn't change for tens of thousands of years. You know, physiologically, no difference between a caveman and an astronaut, right? And then you've got culture, which accumulates over centuries, and you know the tribal identities we have around things like nations and language and things like that. Governance, models of governance, so not governments, but governance, as in the way we choose to run things, whether that's a feudal society or a monarchy or a representative democracy, right? So those things do change, but not too fast, hopefully. Infrastructure, you've got to keep up with the times, you know, this needs to move at a faster pace again. Commerce, much more fast-moving. Commerce needs to, you're kind of getting into the faster timescales there. And then he puts fashion at the top. And by fashion, he means anything that's supposed to be new and exciting. So that would include pop music, for example. And the whole idea with fashion is that it's there to try stuff out and discard it very quickly. You know, what about this? No, what about that? Try this. No, try that. But the good stuff, the stuff that kind of sticks to the wall, will maybe find its way down into the longer-lasting layers. So maybe a really good pop song from fashion ends up becoming part of culture over time. So here's the way that Stewart Brand describes pace layers. He says, fast learns, slow remembers. Fast proposes, and slow disposes. And fast is discontinuous, slow is continuous. Fast and small instructs slow and big by accrued innovation and by occasional revolution, but slow and big controls small and fast by constraint and constancy. And he says, fast gets all our attention, but slow has all the power. Now, pace layers, it's one of those ideas that once you see it, you sort of can't unsee it. You know, like the way when you want to make someone's life a misery, you just teach them about typography, right? And like, now they can't unsee all the terrible kerning in the world. I can't unsee pace layers. Like, I see them whenever I look. Like, does anyone remember this book, UX Designers in the Room, The Elements of User Experience by Jesse James Garrett? It's old now. It's like, we're going back in the way. But in it, he's got this diagram about, you know, the different layers to user experience. You've got the strategy below that finally ends up with an interface at the top. And I look at this and I go, oh, right, it's pace layers. It's literally pace layers. Each layer depending on the layer below, the slower layers at the bottom, the faster moving things at the top. So with this mindset that pace layers are everywhere, I thought, can I map out the web in terms of pace layers, the technology stack of the web? So I'm going to give it a go. And at the lowest stack, the slowest moving, I would say there's the internet itself, as in TCP/IP, the Transmission Control Protocol, Internet Protocol, created by Bob Kahn and Vint Cerf in the 70s, and pretty much unchanged since then. Deliberately dumb, deliberately simple. All it does is move packets around. Pretty much unchanged. Now, on top of that, you get the other protocols that use TCP/IP, like in the case of the web, the Hypertext Transfer Protocol. Now, this has changed over time. We now have HTTP2, but it hasn't been rapid change. It's been gradual, and again, that kind of feels right. It feels good that the HTTP isn't constantly changing underneath us too much. Then what we serve up over HTTP are URLs. Now, I wish that URLs were down here. I wish that URLs were everlasting, never changing. But unfortunately, I must acknowledge that that's not true. Links die. We have to really work hard to keep them alive. I think we should work hard to keep them alive. And what do you put at those URLs? Well, at the simplest level, that's supposed to be plain text, but this is the web, so let's say structured text. This is going to be HTML, the hypertext markup language, which Tim Berners-Lee came up with when he created the World Wide Web. I say came up with, he basically just stole all of it from SGML that scientists at CERN were already using and sprinkled in one or two new tags, as they were calling it back then. So there were maybe like 20-something tags in HTML when Tim Berners-Lee created the web. Now we've got over 100 elements, as we call them. But I feel like I've been able to keep up with the pace of change. I mean, the last big kind of growth spurt with HTML was probably HTML5. That's been a while back now. So it's definitely change that I can keep on top of. Then we have CSS, right? The presentation layer. And that feels like it's been moving at a nice clip lately. I feel like we've been getting a lot of cool stuff in CSS, what with like Flexbox and Grid and all this new stuff that browsers are shipping. But still, I feel like, yeah, this is good. It's right that we get lots of CSS pretty rapidly. It's not completely overwhelming. Then there's the JavaScript ecosystem. And I specifically say the JavaScript ecosystem as opposed to the JavaScript language, because the JavaScript language is being developed at a nice pace, right? I feel like it's going to good speed of standardization. But the ecosystem, the frameworks, the libraries, the build tools, all of that stuff, that feels like, what, try this? No, try that, What about this? What about that? Oh, you're still using that framework? No, we stopped using that last week. Right? Oh, you're still using that build tool? No, that's so, no, we've moved on. I find this very overwhelming. Can I get a show of hands if anybody else feels overwhelmed by this rate of change? All right, keep your hands up, and just look around. I want you to see you are not alone. You are not alone. But I tell you what, after mapping these layers out into the pace layer diagram, I realized, wait a minute. The JavaScript layer, the fashion layer, if you will, it's supposed to be like that. It's supposed to be trying stuff out. Throw this at the wall. No, throw that at the wall. How about this? How about that? And it's true that the good stuff does stick. Like if I think back to the first uses of JavaScript, okay, I'm showing my age, but when JavaScript first came along, we'd use it for things like image rollovers or form validation, right? And these days, if I wanted to do an image rollover, right, you mouse over something and it changes its appearance, I wouldn't use JavaScript, I'd use CSS, right, because we got :hover. And if I was doing a form validation, like, oh, has that field actually been filled in because it's required, and does that field actually look like an email address because it's supposed to be an email address, I wouldn't even use JavaScript, I would use HTML, input type equals email required. So again, the good stuff moves down into the sort of slower layers. Fast learns, slow remembers. The other thing I realized when I diagrammed this out like this is that, this kind of maps to how I approach building on the web. Like, I pretty much take this for granted, that, okay, it's going to be on the internet, not much I can do about that. And then I start thinking about URLs, like URL-first design, the information architecture of a site. I think it's underrated. I think more people should practice URL-first design, URL design in general. I think it's a really good place to start if you're building a product or a service. And then to think about your content in terms of structure. What's the most important thing on this page? That should be an H1. Is this a paragraph? Is it a list? Right? Thinking about the structure first, and then going on to think about the appearance, which is definitely the way you want to go if you're making something responsive. Right? Think about the structure first, then think about the appearance and all these different form factors. And then finally, add in behavior with JavaScript. Whatever HTML and CSS can't do, that's what I'll use JavaScript for, to kind of enhance it from there. So, this maps really nicely to how I personally approach building things on the web. But it is a testament to the flexibility of the World Wide Web that if you don't want to build in this way, you don't have to. If you want, you could build like this. JavaScript's a really powerful language. So if you wanted to do navigations and routing in JavaScript, you can. If you want to inject all your content into the page using JavaScript, you can. CSS in JS, you can, right? I mean, this is pretty much the architecture of a single-page app. It's on the internet, and everything's in JavaScript. It's like the internet's a delivery mechanism for a chunk of JavaScript that does everything. The markup, the CSS, the routing. This isn't how I approach building on the web. And I was kind of asking myself, why is it this doesn't feel quite right to me? And I think it's because of the way it kind of turns everything into a single point of failure, which is the JavaScript, rather than spreading out those points of failure. Right? So we're on the internet, and as long as the JavaScript runs OK, the user gets everything. So it turns what you're building into a binary proposition that either it doesn't work at all or it works great. Those are your only two options. Now, we'll point out that in another medium, this would make complete sense. Like if you're building a native app, if you build an iOS app, and I've got an iOS device, I get 100% of what you've designed and built. But if you're building an iOS app and I have an Android device, I get 0% of what you've designed and built, because you can't install an iOS app on an Android device. Either it works great, doesn't work at all. 100% or 0%. But the web doesn't have to be like that. If you build in that layered way on the web, then maybe I don't get 100% of what you've designed and built, but I don't get 0% either. I'll get something somewhere along the way, hopefully closer to working great, but it goes from not working at all to just about working, works fine, works well, works great. All right, so you're building up these layers of experience. The idea being that nobody gets left behind. Right? Everybody gets something regardless of their device, their network, their browser. Everyone's not going to get the same experience, but everybody gets something. That feels very true to the original sort of founding ideas of the web. And it maps so nicely to our technical stack on the web. The fact that you can start thinking about things like URLs first, then think about the structure, then the presentation, and then the behavior. Now, I'm not the only one who likes thinking in this layered kind of way when it comes to the web. I'm going to quote my friend Ethan Marcotte. He says, "I like designing in layers. I love looking at the design of a page, a pattern, whatever, and thinking about how it will change if, say, fonts aren't available, or JavaScript doesn't work, or if someone doesn't see the design as you or I might and is having the page read aloud to them." So that's a really good point, that when you build in this layered way, you're kind of building in the resilience that something can fall back to a layer a little further down. So this brings up something I've mentioned here before beyond Tellerrand, which is that when we're evaluating technologies, the question we tend to ask is, how well does it work? And that's an absolutely valid question. You're about to try a new tool, a new framework, a new standard. You ask yourself, how well does it work? But I think the more important question to ask is, how well does it fail? What happens if that piece of technology fails? And that's why I like this layered approach, is that this fails really well. JavaScript's no longer a single point of failure. Neither is CSS, frankly. If the CSS never loaded, the user still gets something. Now, this brings up an idea, a principle, that definitely influenced Tim Berners-Lee. It was at the heart of his design principles for the World Wide Web. It's called the principle of least power. It states, choose the least powerful language suitable for a given purpose. Which sounds really counterintuitive. Why would I choose the least powerful language to do something? But it's kind of down to the fact that there's a trade-off. With power, you kind of get a fragility, right? And maybe it's something that's really powerful isn't as universal as something simpler. So it kind of makes sense to figure out the simplest technology you can use to achieve a task. I'll give you an example from my friend Derek Featherstone. He says, in the web front-end stack, HTML, CSS, JavaScript, and ARIA, if you can solve a problem with a simpler solution lower in the stack, you should. It's less fragile, more foolproof, and just works. So again, he's talking about the resilience you get by building in a layered way and choosing the least powerful technology. It's like the classic example being ARIA, right? The first rule of ARIA is don't use ARIA if you don't have to. Right? Rather than using a div and then adding the event handlers and the ARIA roles to make it work just like a button, just use a button, right? Use the simpler technology lower in the stack. Now, I get pushback on this because people will tell me, like, well, that's fine if you're building something simple, but I'm not building something simple, I'm building something complex. And everyone likes to think they're building something complex. Right? Everyone's convinced they're working on really hard things, which makes sense. That's human nature. Like, if you're at a cocktail party and someone says, well, what do you do? And you describe your work, and they say, oh, okay, that sounds really easy. You'd be offended, right? But if you're at a party and someone says, what do? You describe your work, and they go, wow, God, that sounds hard. You're like, yeah. Yeah, it is hard. What I do is hard. So I think we gravitate, especially when something's marketed as, this is a serious tool for serious complex sites. I'm like, that's me. I'm working on a serious complex site. I don't think the reality is quite like that. The reality is just messier, right? There's nothing quite that simple. There's very few things are really that complex. Everything kind of exists on this continuum somewhere along the way. Even the simplest website has some form of interaction, something appy about it, right? Those are those other two terms people use when talking about simple and complex, is like website and web app. As if you can divide the entirety of the whole World Wide Web into two categories, websites and web apps. Again, that just doesn't make sense to me. I think the truth is that things are messier and smooshier between this continuum of websites and web apps. I don't get why we even need this separate word. It's all web stuff. Though, there is this newer term, progressive web app, that I'm kind of fond of. I kind of like it. Who's heard of progressive web apps? All right. Who thinks they have a good handle on what a progressive web app is? Okay, that's a lot fewer hands, which is totally understandable, because if you start Googling what is a progressive web app, you get these Zen-like articles, like it's a state of mind, it's about rich native-like interactions, man. No, it's not. Or worse still, you read like, oh, a progressive web app is a single-page app, and it's like, no, you've lost me there. No, it's not. Or at least it can be, but any website can be a progressive web app. You can elevate a website to be a progressive web app. And I don't mean in some sort of Zen-like fashion. I mean using technologies, 3 particular technologies. You make sure that website is running HTTPS. You have a web app manifest, that's a JSON file with metadata. And you have a service worker that gets installed on the user's device. That's it. These 3 technologies turn a website into a progressive web app. No mystery about it. The tricky bit is that service worker part. It's kind of a weird thing, because it's JavaScript, but it's JavaScript that gets installed on the user's device and then acts like a proxy. It intercepts network requests and can do different things, like grab things from the cache instead of going to the network. I'm not going to go into how it works, because I've written plenty about that in this book, Going Offline. So if you want to know the code, you can go read the book. But I will say that when I first came across service workers, it totally did my head in, because this is my mental model of the web, right? We've got this stack of technologies that we're building on top of, each layer depending on the layer below. And then service workers come along and say, well, actually, you could have a website like this, where the lowest layer, the network, the internet goes away, and the website still works. Like, it took me a while to get my head around that okay, but the service worker file is on the user's device, and if they've got no internet connection, it can still make decisions and serve up something like a custom offline page. Here's a website I run called huffduffer.com. It's for making your own podcast out of found sounds. And if you're offline or the website's down, which happens, and you visit Huffduffer, you get this offline page saying, sorry, you're offline. Not very useful, but it's branded like the site. Okay, it's almost like, the way you have a custom 404 page. Now you can have a custom offline page that sort of matches your site. It's a small thing, but it can be handy. Like, we ran this conference in Brighton 2 years ago, Ampersand. It's a web typography conference, and that also has a very simple offline page that just says, sorry, you're offline, but then it has the bare minimum information you need about the conference, like where is the conference happening, what time does it start, right? You can imagine a restaurant website having this, an offline page that tells you, here's the address, here are the opening hours. I mean, I would like it if restaurant websites had that information when you're online as well, but so I'm saying you can also have fun with this. Like Trivago, their site relies on search, so there's not much you can do when you're offline. So they give you a game to play, the offline maze, right, to keep you entertained. So that's kind of at the simplest level of what you could do, a custom offline page. Then at the other level, I've written this book called Resilient Web Design. A lot of the ideas I'm talking about here are in this book. And the book is a website. Like, you go to the website and you read the book, that's it. It's free. You just go to resilientwebdesign.com. And I mean free. I don't ask for your email address, and I'm not tracking any information at all. So this is how it looks when you're online, and then this is how it looks when you're offline. It is exactly the same. In fact, the moment you visit the website, it basically downloads the whole book. Now, that's the extreme example. In most websites, you wouldn't want to do that because you kind of want the HTML to be fresh. This is never going to get updated. I'm done with this, so I'm totally fine with you go straight to the cache, never even go to the network, right? It's absolutely offline first. You're probably going to want something in between those two extremes. So on my own website, at dactio.com, If you're browsing around the website and you're reading things, that's all fine. But then what if you lose your internet connection? Well, you get the custom offline page. It says, sorry, you're offline. But then also shows you the things you've previously visited. Like, well, you can revisit any of these pages. These have all been cached. So you can cache things as people are browsing around the site. And so that's a nice little pattern that a lot of websites could benefit from. It only suffers from the fact that all I can ever show you is stuff you've already seen. Right? You have to have already visited these pages for them to show up in this list. Another pattern that I think is maybe better from a user experience point is when you put the control in the hands of the user. So this website, archive.deconstruct, this is what it sounds like. It's an archive of its conference talks. We ran a conference called Deconstruct for 10 years, from 2005 to 2015. And breaking news, we're bringing it back for a one-off event next year, September 2020. But anyway, all the talks from 10 years are online here as audio files. And you can browse around and listen to these talks. You'll also see that there's this option to save for offline, exposed in the interface. Now what that does is it doesn't just save the page offline, it also saves the audio offline. So then when you're on an airplane or at the bottom of the ocean or whatever, you can then listen to the things you explicitly asked to be saved offline. It's effectively a podcast player in the browser. So you see how there's a lot of things you can do. There's kind of a lot of layers you can build upon. Once you have a service worker, right, then at the very least you can do caching, because that's the kind of stuff we do anyway, like put this file in the cache, your CSS, your JavaScript, your icons, whatever. Then think about, well, maybe I should have a custom offline page, even if it's just for the branding reasons of having that nice page, just like we have a custom 404 page. Then you start thinking, well, I want the adding to home screen experience to be good. So you've got the web app manifest. You're thinking about how the site, you implement one of those patterns there, allowing the users to save things offline maybe. Also, push notifications are now possible thanks to service workers. It used to be, if you wanted to make someone's life a misery, you had to build a native app to give them push notifications all day long. Now you can make someone's life a misery on the web, too. And there's even more advanced APIs like background sync, where the website can talk to the web server even when that website isn't open in the browser and sync up information. Super powerful stuff. Now, the support for something like Service Worker and the Cache API, almost universal at this point. The support for stuff like background sync, notifications, spottier, not universal. And that's okay, because as long as you're adding these things in layers, then it's fine if something doesn't have universal support, right? It's making something work great, but if someone doesn't get that, it still works good. So it's all about building in that layered way. Now you might think, aha, I've hoisted him by his own petard, because he said that service workers who used JavaScript. So that means they rely on JavaScript. You've made JavaScript a single point of failure. Exactly what I was complaining about with single-page apps, right? There's a difference. With a single-page app, you're relying on JavaScript. The user gets absolutely nothing if JavaScript doesn't work. In the case of service workers, you literally cannot make a website that relies on a service worker. You have to make a website that works first without a service worker and then add the service worker on top. Because think about it. The first time anybody visits the website, even if their browser supports service workers, the service worker is not installed. So you have to build in layers. I think this is why it appeals to me so much. The design of service workers is a layered design. That you have to have something that works first, and then you elevate it. You improve the user experience using these technologies, but you don't rely on it. It's not a single point of failure. It's an enhancement. And that means you can take any website, it's somebody's homepage and a book online, this archive of stuff, something that's more appy, sure, and make it work pretty much like a native app, right? It can appear full screen, add to home screen, be indistinguishable from native apps, so that the latest and greatest browsers and devices get the best experience. They're making full use of the newest technologies. But as well as these things working in the latest and greatest browsers, they still work in the first web browser ever created. You can still look at these things in that very first web browser that Tim Berners-Lee created at worldwideweb.cern.ch. It's like there's an unbroken line over 30 years on the web. We're not talking about the long now when we're talking about 30 years, but in terms of technology, that does feel special. You can also look at the world's first web page in the first ever web browser, but almost more amazingly, you can look at the world's first web page at its original URL in a modern web browser, and it still works. We've managed to make the web so much better with new APIs, new technologies, without breaking it, without breaking that backwards compatibility. There's something special about that. There's something special about the web if you build in layers. So I'm encouraging you to think in terms of layers and use the layers of the web. Thank you.